So let's have a look at the VTP messages in more detail. The first message type is a summary advertisement. VTP summary advertisements are sent every 5 minutes by default, or whenever you make a change. So whenever an administrator makes a change on a switch by, for instance, adding a new VLAN, a summary advertisement will be sent out using the well-known multicast address to all other switches in the VTP domain. This message is used to inform other switches of the new VTP configuration revision number in the VTP domain. So as an example, on switch 1 in this topology, if an administrator adds a new VLAN, let's say VLAN 4, the configuration revision number will be incremented by 1. So if the current revision number is 3, it will now be incremented to 4. The switch will send a summary advertisement to all neighboring switches, informing them of the new configuration revision number. Switches that receive that summary advertisement will then send back a summary request asking for detailed information of the changes that have been made. There are 3 cases when summary requests are used. Firstly, when switches have been reset, or when the VTP domain name has been changed, or when the switch has received a VTP summary advertisement with a higher configuration revision number than its own. So because switch 2 received a summary advertisement from switch 1 with a higher revision number, in other words, switch 1 was advertising a revision number of 4, and the local revision number on switch 2 is 3, switch 2 will now request information from switch 1 so that it can update its database with the latest VLAN information. Detailed information is sent from switch 1 to switch 2 using what's called a subset advertisement. This contains a list of VLAN information, and if there are several VLANs, more than one subset advertisement may be required to update and synchronize the database of other switches. So essentially, what a subset advertisement is detailed information of the changes that have been made to the VLAN database on the switch with the latest revision number. The summary advertisement is used to simply inform a switch in summary format of the latest revision number in the VTP domain. If the local switch sees that it's out of date, it will then request detailed information from the switch with the latest revision number so that the local switch can synchronize its database to that switch. It does that with an advertisement request, and the switch is updated using subset advertisements. The result is that switches end up having the same VLAN database information if they are in the same VTP domain. And if a password was configured, those switches would need to have the same password configured. Now there are 4 VTP modes. The default mode is server. A VTP switch in server mode can create VLANs, modify VLANs, and delete VLANs. Switches configured in VTP server mode also send and forward VTP advertisements. So if the switch receives an advertisement from another switch, it can forward the VTP advertisement on to other switches. If you make changes on the local switch, it would send out summary advertisements to notify other switches of the changes. A VTP server also synchronizes its local database to the latest revision number in the VTP domain, and a VTP server can save the VLAN configuration information locally to the VLAN.dat file. So this is the device where you're going to make your changes by adding, deleting, and modifying VLANs. Multiple switches can be configured as VTP servers, but you need to be careful with this, otherwise you may have switches overwriting each other. The second mode is VTP client. A VTP client cannot create, change, or delete VLANs. The switch is able to send and forward advertisements, however, so it's able to send VTP advertisements about VLANs currently listed in its database to other switches. It will also forward advertisements that it receives from other switches. And in addition, it will also synchronize its database to the latest revision number in the VTP domain. The third mode is transparent. A VTP transparent switches do not participate in VTP. By configuring a switch in the VTP transparent mode, you are essentially disabling VTP. A VTP transparent switch does not advertise its VLAN configuration to other switches, and it does not synchronize its VLAN configuration based on received advertisements. However, be aware that in VTP version 2, a transparent switch will forward received VTP advertisements on its trunk ports. The fourth mode is off. In VTP off mode, a network device functions in the same way as a VTP transparent switch, except it doesn't forward VTP advertisements. So for the CCNA, be aware that we have server mode, client mode, and transparent mode. Server mode is the default and allows you to create VLANs. Server and client VTP switches synchronize their databases. Transparent VTP mode essentially disables VTP, but allows the switch to forward VTP advertisements on to other switches, whereas a VTP off switch doesn't.